Hi guys, this is the first half of the screencast for the Chapter 4 test review. As usual, make sure you go through all of these statements on the first page of the review packet and then into the second page of the review packet to make sure that you can do all these things. Okay, so here we go. Once again, this figure should look extremely familiar to you guys for question 1 on the second page because people still are not getting this question right, which is why this has been on now the fourth consecutive test. Name 2 congruent line segments. Again, look for these vertical lines and the 2 letters that are located on either side of each line. So this is line segment OA. This is line segment OC. They both have these congruency marks on them, and that's your answer. The opposite rays need to be laying on the same number line, going in opposite directions. OA and OC. Work for this. Okay. The ray symbol, some people are still not writing the symbol for a ray, which is an arrow that points to the right. For the ray, the first letter will, if they're opposite, will be the same in both symbols. So OA, OC, you also could answer OB and OD because they're going in opposite directions. Complementary angles, angles that together make up a 90-degree angle. So you are looking for the right angle symbol in the diagram, which is right here. The right angle is this. But the right angle is never part of the 2 complementary angles. They're 2 angles that together make a right angle. So angle EOA, this angle right here, angle EOA, together with angle AOB, angle AOB. These 2 angles together make a 90-degree. Don't give me the 90-degree angle in your answer. That's wrong. Okay, find the indicated value of x in each of these pictures. So this is a repeat from 2 tests ago. This was on 2 tests ago and the last test. So there's a theorem that states an exterior angle, which is an angle outside of this triangle here. So the exterior angle is equal to the sum of the 2 interior angles that are opposite it. Okay, so here's exterior angle D. It's equal to the sum of the 2 opposite interior angles. Now notice this is also an interior angle here, but that's not opposite D. So it's 41 plus 88. Please don't make this harder than you have to. This is not the only way to do it, but this is the easy way. So that's 129 degrees. Okay, X. So this is a polygon that has 1, 2, 3, 4, 5 sides. Okay, these are interior angles. So you guys are going to need the n minus 2 times 180 formula to figure out the sum of all 5 of these interior angles. N is the number of sides. Okay. Since it's got 5 sides, it's 5 minus 2, which is 3, times 180. So the sum of these 5 angles should be 540 degrees. So let's add them together. This is checking to see if you remember that that means 90. So it's 90 plus 145 plus 85 plus x plus x. Let's just make that 2x equals 540. Okay. 90 plus 145 is 135. 135 and 85 is going to equal 220. Okay. So this is 220 plus 2x equals 540, I think, 10. Subtract 220 from both sides. That's going to be 2x is equal to 320. Divide both sides by 2. X is equal to 160 degrees. 160 degrees. Okay. So now we have a triangle PQR. Draw it. PQR. Angle P and angle R are congruent. And then they give me information about the sides of the triangle. Okay. If two angles are congruent, postulate states that their opposite sides are also congruent. So PQ is congruent to QR. Okay. Do we know PQ? PQ is 3x plus 5 is congruent to, but we can just write that as an equal sign. X plus 25 is what they told us that QR is. Solve for x. Subtract x from both sides. That leaves us with 2x plus 5 equals 25. Subtract 5 from both sides. 2x equals 20. Divide both sides by 2. X equals 10. Okay, so that gives me x. Now let's get PQ is equal to 3x. X is 10 plus 5. PQ is 35. Get QR. QR is equal to x plus 25. X is 10. That's also 35. Should they have been the same measure? Yes, because they are congruent. Okay, page 3. Here we have some exponents review. Guys, if the exponent is outside of parentheses, it applies to every single thing that's in the parentheses. So this is the same as 2 cubed a cubed to the third b squared to the third. When you take an exponent to another exponent, you multiply. 2 times 2 times 2 becomes 8. A 2 times 3 is 6. B 2 times 3 is 6. A 8, A to the 6, B to the 6 is the answer. Okay. This next one, get that exponent and distribute it. So it's 3 to the fourth, x squared, 2 times 4. Y 1 times 4. That's me distributing the 4 across. So this is 3 times 3 is 9 times 3 is 27. 27 times 3 is 91. Yeah. 6, 81. 81. So it's 81 x 2 times 4, x to the eighth, y 1 times 4, y to the fourth, over 27 x cubed, y squared. Okay. 27 times 3 is 81. So that reduces to 3 over 1, which is 3. Let's divide x to the eighth by x to the third. When you divide exponents, you subtract them. Let's divide y to the fourth by y to the second. Again, subtract. 3, what's 8 minus 3? It's 5. What's 4 minus 2? It's 2. There's my answer right there. Okay, so this next one, there are no parentheses that I have to worry about. So let's just do our math. So we've got 24 and 16. So I don't know what goes into that. 6? No, 4. No, 6 and 4? 6 times. Well, let's reduce that. Oh, it's 8. 8 times 3 is 24. 8 times 2 is 16. So 24 sixteenths reduces to 3 halves. Now let's divide our exponents. x to the 3 minus 1 because I'm dividing 3 divided by 1, y 10 divided by y 11, which is 10 minus 11. So I have 3x squared over y to the minus 1 over 2 from the 3 halves. I cannot have a negative exponent. What am I going to do? Move them to the bottom. 3x squared over 2y, well, it becomes y to the first on the bottom, but we don't have to write the exponent of 1. It is that. Okay, this one. People are still having problems with this. I have parentheses. I have a negative exponent. My first step is to rewrite the number that are in my parentheses. No, sorry. My first step is to, when I have a negative exponent, my exponent is negative, I'm going to get rid of that negative sign by writing my fraction as its reciprocal, which is 2 over 1. Put the parentheses back and put the 3 back. Okay? So this is really 2 over 1 times 2 over 1 times 2 over 1. 2 times 2 is 4 times 2 is 8. 8 is my simplified version of that. Okay, because 1 times 1 times 1 is 1. We don't have to write that. Okay. So we have a triangle congruency problem next. Let's take a quick look. Okay. This is postulate congruency statements. Okay. So I've got these two angles congruent. These two sides are congruent. And I've got two vertical angles here. So those vertical angles are congruent to each other. So I have angle, side, angle, angle, side, angle. Okay. So here's A. Let me get rid of my angle, side, angle. A little confusing. Okay. A, B, C. Now, what triangle is that congruent to? Okay. Triangle. A is congruent to D. Look where it sits. A has neither side on either side of that angle with a congruency sign. Look at D up there. Neither side next to it has a congruency sign. So A and D are congruent. Okay. B, B has this angle. E has this angle. B and E are congruent, which means that C is congruent to C. Triangle, DEC. All right, now DC is congruent to, here's D, here's C, congruent to AC. They occupy the same positions in the triangle congruency statement. And then finally, angle CBA is congruent to what angle? Well, C is congruent to C. B is congruent to E, so E comes next because B is second here, E is second there, and A is congruent to D, so it's angle CED. Okay, last question on page 3. They want me to solve for both X and Y, and I have a triangle that has two congruent sides here. This is triangle A, we'll call him, and triangle B has two congruent sides here. Okay, so let's solve for X. What jumps out at me right away are these two angles, because you learned that for isosceles triangles, when they have two congruent sides, when a triangle has two congruent sides, the opposite angles are also congruent to each other. So this angle, because it's across from this side, is congruent to this angle here because it's across from this side. So if these two angles here and here are congruent, then that must mean that their measures are congruent. So 3x plus 10 and 5x minus 10 are congruent. Okay. So let's solve for x by subtracting 3x from both sides. That gets rid of that. This gives me 10 is equal to 2x minus 10. Now we want to get rid of the 10 from this side, so let's add 10 to both sides. These go away. Oh, sorry. This becomes 10 plus 10, which is 20. These go away. 20 is equal to 2x. Divide both sides by 2. X is equal to 10. Okay. So x is equal to 10. Um, so what is that going to get me? If x is equal to 10, then I can figure out what the measure of this angle is and this angle, which will give me angle number 3 up here, which will help me figure out y. Okay, just bear with me. If x is 10 and this angle is 3x plus 10, 3x, if x is 10, that's 30 plus 10, it's 40. This is 50 minus 10, that's 40. So if this angle is 40 degrees, this guy right here, and this guy right here is 40 degrees, what is the angle at the top of this triangle equal to? Well, angle question mark plus 40 plus 40, the sum of the interior angles of a triangle are 180. So that angle is equal to 180 minus 80, which is 100 degrees. Okay. So if this angle right here is 100 degrees, what's the angle right next to it? Right? Look at these two angles. This angle right here and the guy right next to him. Aren't they supplementary? Right? These two angles right here. And angle if this angle is 100, doesn't the guy right next to him have to be 80? Right? Those two angles are supplementary. I- So uh, now, if this side, so now we're dealing with this triangle right here. Okay, this guy, this guy, this guy. If these two sides are congruent, then their opposite angles are congruent. So this angle here is congruent to this guy right here. We just figured out that the measure of this angle is 80. And if this guy is 4y and they're the same, doesn't 4y equal 80? Divide both sides by 4. That little y right there should be 20. Okay, that's a tough one. All right, now I'm going to pause this. This will be screencast number 1. Um, and let's see. Yeah, this will be screencast. Do I want to keep going with this? I don't think I do. So let's stop this and